Hi students, this is session 5. So today we are going to see the half range cosine series. So first, we knew that what is a half range cosine series? That the half range cosine series is nothing but it is an even function. So we already studied the even. What is the even function and odd function? So even function we need calculate a naught and a n. There here bn is equal to 0, but here you no need to apply bn is equal to 0. So just to find the a naught and a n value. So this is the half range cosine series. So now we are going to see the half range cosine series in 0, l interval. So this is a Fourier series for the half range cosine series. F of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos n by x by l, where a naught is equal to 2 by l 0 to l f of x dx, a n is equal to 2 by l 0 to l f of x cos n by x by l into dx. So there in a even and odd function, we need to check whether the function is even or odd. But here they will give in the question itself, they will give the find the half range cosine series. So cosine series is you calculate only the a naught and a n value. So I have to consider the from the half of the interval. So 2 to l integral 0 to l. Only I have to consider, not consider for the minus l to l. So here I have to consider the half interval 0 to l. The similarly a n values also. So now we are going to see the formula for under the 0 comma pi. So half range cosine series in 0 comma pi is given by f of x is equal to the same Fourier series a naught by 2 plus summation n is equal to 1 to infinity a n cos nx. So here a naught is equal to 2 by pi integral 0 to pi f of x dx. A n is equal to 2 by l integral 0 to pi f of x cos nx dx. So this is a formula for half range cosine series in 0 comma l and 0 comma pi. So next we are going to see the problem. Find the half range cosine series and sine series for f of x is equal to x square in 0 comma pi. So half range cosine series, that is we have to that is a even function only. So for this even function we need calculate only the a naught value and a n value. So a naught is equal to 2 by pi integral, so it comes under the interval 0 to pi. So integral 0 to pi f of x cos nx dx. So here apply 2 by pi integral 0 to pi x square. What is our f of x is given? X square into cos nx dx 2 by pi. So here you have to use the Bernoulli formula. Consider u is equal to x square. Then u dash is equal to 2x, u double dash is equal to 2. So similarly, dv is equal to cos nx dx. So integration of first time we get the sin nx by n. Then the second time we get the minus cos nx by n square. Then third time we'll get the minus sin nx by n cube. So now applying the limit 0 to pi. If you apply the pi, so here we have sin n pi value 0. Then here also sin n pi value 0. So only consider that this cos n pi. So minus 2 pi minus into minus plus then 2 pi cos n pi by n square. So cos n pi value we know that minus 1 the whole power n. So 4 into minus 1 whole power n by n square. Then next go for the lower limit. So here 0 into anything you will get the 0. So already we know the sin 0 value 0. Here also sin 0 value 0. So therefore we got the a n is equal to my 4 into minus 1 the whole power n by n square. So next we are going to see the a naught value. So a naught is equal to 2 by pi integral 0 to pi f of x dx. What is our f of x is given? X square. So here f of x is equal to x square substitute. Then after integration applying the limit we get the value 2 by 3 into pi square. So now we are going to write the half range cosine series of x square is given by. So f of x is what is given? X square given. So instead of f of x substitute x square which is equal to a naught by 2. So 2 pi square by 3. So therefore 2 cancel. So we can write pi square by 3 plus 4 into summation n is equal to 1 to infinity minus 1 whole power n by n square cos nx. Next we are going to see the half range sine series. So f of x in the 0 comma pi, we should have this sine series sine is an odd function. So here we need calculate only the bn value. So no need to calculate the a naught and a n. So the Fourier half range sine series is f of x is equal to summation n is equal to 1 to infinity bn sin nx. So bn formula is equal to 2 by pi 0 to pi f of x sin nx dx. So 2 by pi f of x is what is given? X square is given. So here f of x equal to x square substitute. Then now we use the Bernoulli formula x square u is equal to x square, then dv is equal to sin nx dx. So now differentiating the x square you get the minus 2x. Then again differentiating of 2x you'll get the 2. Then integration of sin nx is minus cos nx by n. Then again integration of this cos is sin nx by n square. Then again integrate get the cos nx by n cube. So now we are going to apply the limit 0 to pi. If you apply the upper limit, that's the first term you will get the cos n pi. So cos n pi value we know that. Then sin n pi value is 0. In the last term also cos n pi we have the value. Then from first and the second last term only we get the value. So therefore pi square. So instead of x substitute pi. So pi square by n into minus 1 whole power n plus 1. So already this minus is having. So that minus is also included. So that can be written as minus 1 whole power n plus 1. Then here 2 by n cube into. So minus 1 the whole power n. Then next apply the lower limit 0. For the first term 0 into anything 0. In the last term only we will get the cos 0 1 by n cube. So from both the term they can take out the 2 by n cube. For upper limit applying we get the minus 1 whole per n. For applying the lower limit we get the minus 1. So now both combined and we can write it as 2 by pi is a common. Then pi square by n is common. Then minus 4 by n cube is common. So they are taken if it is here, if you substitute n is equal to odd value. So minus 2. So minus 4 by n cube will come. If n is even value it become a 0. So minus 4 by n cube having. So from both the term they can take out the 2 by pi common. So pi square by n minus 4 by n cube. If n is odd. Using this value into we get the half range sine series of x square in 0 comma pi. Next we are going to see the next problem. Obtain the half range cosine series for f of x is equal to x minus 2 the whole square in the interval 0 less than x less than 2. Deduce that summation n is equal to 1 to infinity 1 by 2n minus 1 the whole square which is equal to pi square by 8. So here it is comes under the interval 0 comma l. So l only they give the constant value. In a pi they won't give the constant value. So here we have to consider l is equal to 2. So here now we have to find the Fourier series for this given f of x. So it comes under the half range cosine series. Half range cosine series we need calculate only the a naught value and a n value. The Fourier series for half range cosine series is f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos n pi x by l. So here I already explained that what is it l is equal to 2. So here is substitute l is equal to 2. Next one, we are going to find the a naught value. Say a naught is equal to, so 2 by L will come. So L value already 2. So 2 will cancel. So in the before the integral, no multiple term is having. So only 0 to 2 f of x dx. What is the f of x is given? X minus 2 the whole square into dx. So now we have to expand this one. X minus 2 the whole square expansion is x square minus 4x plus 4. So after that expansion, I have to integrate. So x square integration is x cube. 2x integration is 4x integration is 4x square by 2. Then integration of 4 is 4x. Then apply the limit 0 to 2. So we'll get the a naught value is equal to 8. Next we go for the an. An is equal to, here also you'll get the 2 by L. So L is equal to 2, we know that. So if you substitute L is equal to 2, so here 2 by 2 is 1. Then integral 0 to 2 f of x cos n by x by L into dx. So L is equal to 2 here. So substitute L is equal to 2. Then here I have to use f of x is equal to x minus 2 the whole square. So now we use the Bernoulli formula. So consider here x minus 2 the whole square as is equal to u. Then dv is equal to cos n by x by 2. So now using the Bernoulli formula, we got the result like this. Then apply the limit 0 to 2. If you apply the 2, the first term won't come. That is a 2. If you apply 2 will cancel, you get the sin n pi. So we already know sin n pi value is 0. Now similarly here if you apply, that is 2 minus 2 0, then this term also won't come. Then this term also won't come. So while if applying the upper limit, all the terms become a 0. Then next go for the lower limit. So first term sin 0 value is 0. So here cos 0 1, but here if you apply 0 you will get the minus 2. So minus into minus plus 4, this minus is having, so minus 4 cos 0 value 1. So 1 by n square pi square by 4. So this 4 multiply you will get the 16 by n square pi square. So a n value we got 16 by n square pi square. So f of x is equal to 4 plus, that is a naught is equal to 4 plus 16 into, that is a naught by 2, a naught value 8, 8 by 2 will get the 4 plus 16 into summation n is equal to 1 to infinity 1 by n square pi square cos n pi x by 2. That's all. So next we are going to see the half range sine series for the next session. Thank you.